Hi, today we're talking about specific heat and equilibrium. So for the first part, we've got aluminum and we have 550 grams of it. We take that and we heat it up to 150 degrees Celsius. The next part is water. We have a mass of 100 grams of water and we heat that to 25 degrees Celsius. So what we want to find is the resulting equilibrium temperature when you add those two things together. Well, we know that the Q of aluminum plus the Q of H2O is going to equal 0. And the reason why that is as one lets off heat, the other is going to take on heat. And that's going to be the equilibrium, and it's going to equal 0. Okay, so the first thing we need to do is find the Q of aluminum. So we take Q of aluminum is going to equal the specific heat of aluminum times the mass of aluminum times the delta T. And the delta T is going to be your temperature final minus your temperature initial, as always. Now we need to find the Q of water. So we take the Q of H2O is going to equal the specific heat of H2O times the mass of H2O times delta T, which again is going to be temperature final minus temperature initial. Now, what we're going to do is we're going to add these two together and we're going to set them equal to 0. So the specific heat of aluminum is 900. And you're going to multiply that times the mass of aluminum, and we have 550 grams, but we have to convert that to kilograms, so that's going to be 0.55 kilograms. Okay, and then we've got to times it times the change in temperature, which is going to be TF minus T initial. Now we don't know what the equilibrium is going to be, but that's going to be TF. So we're going to say that's TF minus the temperature initial of the aluminum, and we know that's at 150 degrees Celsius. So put 150. Okay, now that's for Q aluminum. Now we have to add that plus Q of water. And Q of water is a specific heat of water, which is 4186 times the mass of the water, which is 100 grams. We convert that to kilograms and we get 0.1 kilogram times the change, which we don't know yet, the temperature final minus the initial, which was 25 degrees Celsius. And we're going to set that equal to 0, just like up here. Okay, so 900 times 0.55, that's going to give us 495. And then we still have got TF minus 150. Okay, and then plus 4186 times 0.1 is going to give us 418.6 times temperature final minus 25 right here. Okay, we're going to set that equal to 0. Now what we're doing here is we're solving for TF, okay? That's going to be the equilibrium temperature. Alright, so 495 times TF minus 495 times 150, which is going to give us 74250. Alright, then we're going to plus 418 times TF, 418.6 times TF minus 418.6 times 25, which gives us 10,465, and it's going to be equal to 0. Alright, so now let's add these TFs up. We've got 495 TF plus 418.6 TF, and that's going to give us 913.6 TF. Okay. And then we're going to subtract minus the 74250 and 10465 is going to be 84715. So we're going to say minus 84715, and that's going to be equal to 0. So now we're going to throw this bad boy over here, and it's going to give us 913.6 TF is going to be equal to 84715. Remember, we change the sign when we bring it over. And then all you have to do to get TF is divide 84715 by 913.6. So you're going to get 84715 divided by 913.6, and that's going to give you 92.73 degrees Celsius, and that is the resulting equilibrium.